In this video we're going to talk about SD-WAN and cloud connectivity. Why is this important? The reason that it's important is that we are seeing the biggest shift in networking since probably voice went to IPT and VoIP. In the WAN space specifically, SD-WAN has been around for maybe 5 years at the time of recording this video, late 2021, and let me explain a few parts about what SD-WAN actually is. If you have your data center with services and then a load of remote sites down here that all connect into, let's say, an MPLS network. All sites connect into that MPLS network, as does the data center. Sometimes we had connectivity from a WAN perspective to the internet, or via the internet, I should say, where we build IPsec tunnels over the top in order to get to secure back-end services. This network was deemed as secure, so these sites down at the bottom always had secure connectivity into the servers that were located in the data center. And this is conceptual, so it could illustrate a single data center or multiple data centers. But just to confirm, the dashed line is an IPsec VPN. And you might say, well, what's wrong with that model? But there's nothing wrong with it. Things have evolved though. But when it comes down to it, we basically have two networks. We have this network to manage, which might be managed wires only by an enterprise, or it might be fully managed by an ISP. By the same token, the IPsec VPN network, which is this dashed line going from this site into the data center, you might have 100 of these, and that is typically managed wires only or in-house. So you can see here, if you had 100 MPLS and 100 IPsec VPN, pretty much just wanting to get back to the servers, then it can become quite complicated. If we now talk about the new networking landscape, and we don't just have a data center, what we normally have now is a data center with servers still, sure, but we also have multiple cloud platforms. So let's just use some examples. AWS, Azure from Microsoft, GCP, Google, and other. Now, the challenge that we have here is that we also have different reasons to access these cloud services. So let's just keep it to the most common ones and say software as a service and infrastructure as a service. If you think about software as a service, and we illustrate this like that, we typically need an internet connection to access these. And we can normally go over HTTPS, directly over the internet, but sometimes it might be restricted in some way in order to access these applications. For example, it might only be allowed with IP whitelisting. What that means is that you can only come from a certain IP address. So this could be you on your laptop trying to access one of these software as a service. By the same token, if you wanted to access the data center, which is connected to the internet, we would be talking about the IPsec VPN to connect into the server environment. If we draw the MPLS network back in, which may or may not be around, and we say that there's still sites connected to the MPLS, the data center is connected to the MPLS, but if the site is not connected to the internet, what do we do? How do we access these cloud applications? Let's talk through some options. Okay, so if we have a data center that needs to access, let's say, AWS, and there's some servers, now we're talking about infrastructure as a service. If we have servers at the back end, virtual machines effectively hosted on the cloud hosting infrastructure, and we need to get to these from this laptop, this router, or this location, which is an internet-based site, because many people deploying SD-WAN are using internet as a connectivity mechanism. Now let's talk about how we can access these services up at the top of the diagram. So AWS, Azure, GCP, other cloud hosting platforms. We have a few different options. Now this data center could be the enterprise data center, or it could be a co-location, like an Equinix data center or something like that. The options, if we take from the data center perspective, we can effectively, in order to access these servers, just bear in mind that this is what we're trying to access in the context of this discussion, we can effectively have what we call cross connects into these different providers. Private cross connects, more often if it's in a co-location space, because we normally have the capability to go to AWS, Azure, etc., and others from these tier 1 data centers. So if we have a connection or host our stuff into a tier 1 data center, these green lines that I've drawn in are effectively cross connects, and that provides private connectivity. Another way that we can access these data centers or cloud platforms is if we have an SD-WAN, and I'm just going to illustrate that by putting the dots here, and let's just say we have some sort of SD-WAN appliance in each of these data centers or platforms in these data centers, cloud data centers I should say, and those are connected to the internet, or they could be connected to the MPLS. I'll just draw one here. Okay, so now we have a couple of different connectivity methods that we can access the cloud platforms, and these routers now, if you think of them as SD-WAN appliances, what is SD-WAN? So SD-WAN, we might have in this picture two different connectivity methods. We have MPLS and internet, but there might also be, I don't know, 4G cellular that is a backup link and comes in over the internet. And then what we can do if you imagine how many different transport and types there are, we can effectively create overlay networks on top of these platforms and make it look like one big network. And then what we have is these cloud providers connected into the blue networks, or the blue network overlay, and also the remote sites, and also the data center. I've not drawn a router in there, but you can imagine it's just another router in the data center that's an SD-WAN appliance. The idea of this is that regardless of what your connectivity method is, you can access the blue overlay network. And this also gives you many different options as to how you can connect into the cloud environment to access these servers at the top. The final thing for this video, in the interest of keeping it fairly short, is that when you have the different paths into the data center, into the cloud platforms, with SD-WAN, you're able to define application routing policies that say, if Office 365, then send over internet. If the internet is down, then 4G. And then via the data center. So the final thing to say on this particular video is that what we're saying here, if we have a red traffic flow, and this site has to get to this data center up here, the red traffic flow will come in over the blue network and in as the primary. If that primary fails here, then it will come over the internet and go over the 4G network. And if the 4G network was down, and this was also, let's just say it was connected into the MPLS, it could also come that way. The objective of this video is really to demonstrate the complexities that exist with SD-WAN, and this is only scraping the surface. We're going to do more SD-WAN training courses at MNB Networks, and if you visit our website training.mnbnetworks.tech, we will be launching other courses in 2022 that really explain SD-WAN connectivity to the cloud, but also within the enterprise environment. We're also working with customers on how SD-WAN impacts the service provider. So if you think about the underlay and the overlay, how do you do traffic engineering in the underlay when you have an SD-WAN overlay passing most of your traffic? Just a few points to think about there. I hope you enjoyed the video, and thank you for your attention.